The next presenter, Sylvain Jutras. He's a professor at the Department of Science of Forest and Lumber at Université Laval. He's going to talk about water and the issues around water and using LiDAR technology. Thank you. I made two decisions yesterday. I said I will be like Martin and I'm going to wear a suit coat. And to help us all with our mental health, I decided to put no images in my presentation that contain LiDAR data. But I'm going to talk about LiDAR. So I teach at the Faculty of Forestry about hydrology. Forest hydrology is taking care of the impacts of forestry on the water. It's planning the wood harvest, forestry work, and we have to upkeep and build road networks. So that's a summary. If you want more information, you can take the course with André Plamondon, and the Chapter 5 of the Forestry Manual has all the information. What I teach is that the major threat is sediments. All our rules and laws. Since we cut wood, of course there's going to be erosion. What we want to avoid is during the transportation, we want to reduce ruts. So cutting areas, we want to reduce them to 25%. We want to perturb the soil as little as possible. And buffer zones, it's the soil that filters the water. The water has to go to the hydrographic area. So if we have buffer zones, we can keep the sediments from going into the water. We need 5 meters and 20 meters for rivers. This is one of the main threats. Another threat is the road network, the forestry road network. Technically, we know how to build crossings, roads, in order to minimize the impact on the water. So if we have the RADF, we have the RNI, these are all good management practices. Every time we have a crossing that becomes no longer usable, think about beavers and all these problems that can occur. That's when sediments accumulate. And there's no rules that oblige people to upkeep these crossings. These crossings and these... and Philippe Paradis-Lacombe did a project last year. He's starting to get results. And the impact of the road network of the forest industry, we have 600,000 kilometers in Quebec, 400,000 kilometers are roadways in forest. We have 200 kilometers of roadway that have no one has statute. No one has decided if they are being used, if they're not being used. We have a database of 2,200 bridges, but we have no information about the So we made 13 catchment areas for the culverts. Within these catchment areas, you see in purple, we have catchment areas. We didn't choose roads. We chose a territory, and we inventoried all of the crossings, all of the bridges, all of the roads. So we We made an inventory of 500 kilometers of roadways. So we couldn't travel very easily, but almost 50% of the roadways were abandoned and not upkept. So that's just a sampling that we did. That's a random sampling. It's a big territory, but it represents well the state of our roads. So a big problem. We measured and we inventoried 400 crossings, and we have 78% that are in a bad state of affairs, and they are a threat to the water, the quality of water. What you see in red, that's one crossing out of each 5 crossings that's in a bad, critical state of affairs. So they are a threat to the quality of water. So what does it look like? It looks like this. You see up top, we calculated the volume of sand going through the culvert. And these are important threats to the quality of water. So right now, what I'm teaching my students is that the issues around water in forestry, harvesting is not a big threat to the quality of water, but, however, as Mr. Woods was saying, this is a case of surprise forestry. The scale of what's going on and the construction of roads, we have imprecise information. We would need a better planning of the constraints. Right now, we are not upkeeping our roadways, and it's becoming a serious threat to the quality of water. The management of our roadways is not comprehensive right now. In certain places, we manage priority access ways, but we're not taking care of roadways that are less used. So it's only been 30 years that we've started installing metal in our roadways. A metal tube is 25 years of use, and then it starts to rust. So we have imprecise mapping tools. We only know about 45% of the crossings and the culverts that are upkept. So we're missing a lot of information, and this is where LiDAR technology can be very important and very interesting, because what would be interesting would be to improve the mapping of the of the waterways, so we can figure out the flow of water. And with this technology, it's exactly the same of what we see in the field. So it's phenomenal. It matches the information that we already had. It's only several clicks, but we have to smooth out our DTM models. We don't have the information of where the culverts are, because we can't see it from above. So the waterways are ending up in places where they shouldn't end up. When we map the waterways, they end up in places that we don't expect. So we don't have the data that will allow us to plan precisely. So sometimes the catchment, the watersheds, the information for the watersheds is incomplete. So we have LiDAR parts of the information, but when we start mapping, it has to be comprehensive from the beginning to the end of the watershed. And every time we look at surface area for waterways, the information is incomplete. And we're using random information, random samples, and so we say, okay, well, I'm going to start my intermittent stream here, but it depends on the type of soil, on the on the slope. So this has to be completed by data that comes from the terrain. So how can we map our waterways? Our shorelines without ribboning. We talked a little bit about that yesterday. Optimized planning. In certain situations, we'll build less roads, and we could perhaps reuse old roads. So often people build new roads and they don't even take into account the old roads that exist already. So if with LiDAR information, they could take that information into account, because there are many roads that are not even mapped. They're nowhere. But when we get there on the terrain, we notice that there are culverts that are blocked and other aspects that have not been noted. In the new RADF, there will be a lot more culvert dimensions to be collected. So with LiDAR technology, we'll be able to have a more precise idea. What else could we do? This is a little slide about going further with hydrology. Rethinking the donut in 2002 by Jim Buttle. His idea is that the buffer strips or shorelines, why do we have 20 meters? Why do we have 5 meters? Well, it's throughout history, we've had different reasons to decide for 5 meters or 20 meter shorelines or buffer zones. We know now each pixel for a waterway, how much water flows in and out. So now we can know. It's random to figure out the flow of a waterway because it changes over time, over the seasons. So the hydrological zones, we have the tools to do it now, to establish them now. It's nice to invest in this technology, but we have to have a way to implement it. Another point in hydrology, it's very important, is to improve the mapping of the soil, the intensity of the signal plus the DTM. With that equation, we can generate topographic wetness indexes, depth to water tables, and these are very useful for soils that often have ruts, wetlands, and these are tools that can be easily used. Perhaps we need a calibration for the Canadian. There are many thresholds. You could do the topographic wetness index tomorrow morning, but would it be efficient? This mapping will reduce rutting. We'll get better harvesting, how to drain, but and it will influence our road networks. But perhaps for water, the forest, and the potential of LiDAR, I think there's enormous potential. Hydrology, watershed areas, wetlands. So solutions exist. Yes, perhaps tomorrow morning you could generate all this information. Yes, I'm inviting you to do it, of course. But there's a lot of manual correction to be done. There's a lot of validation. You can do it in each of your fields. It's being done for the whole of Quebec. But we need more research for water issues, and I hope that legislators will do the same thing. It's all nice to have all this data, but we need a comprehensive strategy. It's the government that owns this road network, but we don't have sufficient information to manage it well right now. So this is what we're faced with. Several departments are communicating and working, collaborating, but it's a very, very important issue for the protection of our water, the quality of our water. Thank you.